I'm not going to stand behind the podium if that's all right. I like to move around so I don't fall asleep. You know, why do a pool coat? I'm not going to tell you about what we're going to actually cover. Anybody here have a pool? Well, that's good, because if you do, I might recommend you leave before I show you some of these pictures. These pools are not rectangular ponds in the back anymore. Infinity edges. We have to get a very close tolerance. Hillsides. We have to deal with the water flow, getting water stabilized. That's not part of the concrete, but we have some very, very complicated structures. Here you can see infinity edges. Here you can see this is actually the infinity edge with a nice waterfall over this. All of these are done with Shotcrete construction. Shotcrete's the predominant concrete placement method for pools. This one's got an acrylic window on the edge, incorporating that, keeping it watertight. Pools are expected to hold water. And here you can see on a hillside looking out in North Carolina. This one's multiple levels, give you an idea of how the structures interact. And all of these have liquid forces, as well as the structural loads from being a part of a cantilever on a hillside. Here's another shot of that same one. You can see the different levels. This is steel that we see in a pool. That's a well-designed pool. We get hillsides like this. How do you form it up? You know, coming in on a hillside, especially a residential area where you have a neighborhood and you got to get in and have access. But this is what we are seeing more and more. What's going to happen to that bottom steel? Can you see the bottom steel on the floor, back in the back? Is it up off the soil? No. You know what? They're using, a lot of these pools have a 10-inch thick wall. They're using number 3 bars at 12 inches as their horizontal temperature and shrinkage steel. Anybody 318? You know what's the number for shrinkage and temperature steel? Oh no, somebody's got to know. 0.18%. Number 3's at 12 is half that. They're not even putting in the amount that's needed in 318. Here's a wall. Oh, well, I designed this wall 10 inches thick. Can you see what's back behind the steel? They over-excavated, or they had a rainstorm. Look at the water. What's this sitting here? I don't know if that's a little sump pump. They basically pumped out the water from the rainfall. Here you can see, they actually tied some of the bars together, but you know, trying to get the curve through here. This one, steel right up against the soil. What are we supposed to get for cover for steel, you know, away from the surface of the soil? I don't think that's an EFCO form. A lot of times using a very lightweight form, sometimes a stay form. They're not taking care in building these structures. And remember those first pictures, pools are expensive. Most of those that I showed you are between $1 and $2 million. That is an awesome amount of money to build a structure that we found doesn't have a specific design code for it. Today's pool design and construction, it goes all the way from, remember the shot with all the steel, it looked like a nice reinforced concrete tank that we might do in ACI 350. But I have some states, like Tennessee, where some states do require a licensed professional engineer for all the pools. Some require it for a commercial pool, but there are many that don't require any licensed design professional to design the pool. And there are Shotcrete or there are pool builders who are downloading designs from the internet. They haven't evaluated the soil, they haven't looked at the load requirements. They basically are just shooting from the hip. And actually, there are pool builders out there who have been using the same design for decades. Oh, it worked 20 years ago, it worked 30 years ago, why change? Well, you know, the owners are paying a lot of money. They ought to be able to get something that should last 50 to 100 years. In ACI 350, we say if you design that structure by ACI 350, you should expect a 50 to 100 year life. So where are we at today in code requirements? There is an International Swimming Pool and Spa Code. This is part of ICC, the International Code Council. And they have basically for that swimming pool, the quote, the structural design material shall be in accordance with the International Residential Code. Oh, well, that's helpful. So I go to the International Residential Code, and it says, what's it do? Say anything about pools? Say anything about watertight? 1 and 2 family dwellings and townhouses? And then you go with, the only thing that I could find that really dealt with what we would do with a pool, buildings that are not within the scope of this section shall be designed in accordance with PCA 100 or ACI 318. Okay, well now we can do 318. That's cool. And what is 318? It's a building code for structural buildings. It doesn't deal with crack control for water tightness. Cracking in building structures, anything more than a 5 mil crack will leak. A 5 mil through crack will leak. And 318 does not have the amount of steel, the spacing of steel to control cracks, and it's not really designed for structures that are continuously exposed to water, wetting and drying. So we do have a code. We've got the chair of the code right here, ACI 350. I chaired the code when we did the first one in 2001. Environmental engineering concrete structures, that really means tanks. That is a good code, and in fact, many commercial pool designers do use ACI 350. It is designed, we use more steel, we space it closer together, we look at exposure conditions, the durability durability code we talked about, we look at chemical exposures and various things. But there's a whole lot of stuff in that ACI 350. It's thicker than 318, I think. At least it's about the same thickness. But there's things like shear walls, roofs. We don't have a roof on a pool. We don't generally have beams, though we do have some pile-supported floors, columns. Torsion, do you get torsion in a pool? Do we have a rotating mechanism? Probably not. We don't have pre-stressing in pools. We don't have precast. So what's the designer supposed to do? Well, maybe I'll do 318, and I have a lot of pool designers, well, I just use 318. That's what I learned in school. And they go with that 0.18% reinforcing for temperature and shrinkage. If I go to 350, I'm probably closer to 0.5%, and with a new 350, maybe even more, depending on the level of restraint. That's a big difference. And I get people who say, well, we don't need it in pools because we're going to put plaster on the surface. What is plaster? If there's a crack in the concrete shell, what do you think is going to happen in the plaster? And the plaster is really a coating. It doesn't really have that much strength. Anybody here in the plaster committee? We do have some that participate. So, what do we do? These pools are becoming more and more complex. Infinity edges. You saw the acrylic window. How do we incorporate that? How do we have those stresses when we have a free-form pool? A rectangular pool, probably pretty easy. We can design that with panels and have a pretty good approach. But when you have a free form that there's no straight edges, you have to do a lot of kind of interpolation. How am I going to deal with that on a design? They're expensive and have a major investment on the part of either the owner or municipalities. And we have municipalities that are doing large commercial pools. They're doing lazy rivers. Anybody do a lazy river? Where you get to the raft and it goes around and around, and some of those are several hundred feet long. and if you're designing it by 318, it's not going to hold water. So we needed to come up, and I recommended to TAC, I forget how, probably 2 or 3 years ago, maybe longer. Hey, we really need something to address this because I'm technical director at ASA, American Shotcrete Association, and I can tell you, I get calls from owners. Well, I got this crack in my pool. You know, why did that happen? And I say, well, you know, what was the steel layout? And, oh, number 3's a 12. Did you ever see anything ever shoveled out of it? Well, it was shotcreted and there was rebound and trimmings. It was obvious that the owners, they don't have the sophistication to know what to tell that pool designer to do. And so we need to have some more specific guidance. So we came up with the ACI code 322. And what we're doing is looking at ACI 350 and saying, what things do we not need out of 350 that we can do for pools? We're also looking at 318. So we got these 2 big books that we're trying to come up with some middle ground, some consensus in terms of, you know, what is the appropriate amount of steel? Do we go more with the higher amount of steel, closer spacing out of a 350 than what you get out of 318? Looking at the specific requirements for pools, because most of them are full once they're in service, but we have to generally consider a lot of times that pool's built but sits empty for a month or 2 months or a year until they get the plaster and the tile. So sequence-wise, they have to look at the drying shrinkage as being something critical. This shows you some complexity. This is a shotcrete project. Here's a pool wall. This is exposed, so this is above ground. This is in ground, and all this was shotcreted. Now that's not part of the pool, and it's a slide, a water slide. But it shows you some of the complexity that we have in pools, and it really deserves a code. It deserves something that designers can use, that we can work with and have the International Swimming Pool and Spa Code actually reference a code that's specific to their product. This is a view of it finished. And that's it. I'm bringing us back on time, in fact, a little early. Any questions? I'm surprised we don't have anybody with pools here. It has really been a challenge bringing together, because we have a lot of people on our committee who are pool designers. They haven't been involved in ACI. They don't know necessarily how we work with the technical committees and the balloting, and we'll get ours done before 2061, I guarantee that.